Okay, this is exercise 3.9, question 16. Find the volume of the solid formed when the curve y equals square root of x is rotated about the y-axis between y equals 1 and 4. The main thing with volumes is to write the formula out. So, if it's rotate about the y-axis, then it's the dy formula. If it's rotated about the x-axis, it's the dx formula. So the first thing you should always do with volume questions is to write out the formula. So the dy1 has x squared dy. It's not y squared dy, it's x squared dy. Let's have a look at your function. You've got y equals root x. What am I going to do with it? I need to get x squared. So what should I do first? Get rid of the square root first. Square both sides and you get x is y squared. You're squaring both sides. And therefore x squared is y squared squared, which is y to the power of 4. Are we okay? So please, writing out the formula, making sure you come up with your x squared. So you need to get rid of the square root sign first, squaring both sides. And then you'll need to square both sides again. Okay? Just focusing here. Okay, so what have we got? Volume is. Now, you can draw a quick sketch if you want. You know how I've squared both sides and I had y equals square root of x? We say, where did that curve originate from? It came from x equals y squared. We're used to seeing y equals x squared. So this is the positive type parabola shifted sideways. Instead of being y is x squared, it's x is y squared. These are my positive x values. It actually goes like that. But I just want the top curve, y equals square root of x. Is that the top or the bottom of this? What I've just drawn. It's the top half. So this is y equals root x up here. And it's rotated about the y-axis between the values of 1 and 4. It doesn't have to be a fantastic sketch. Again, because it's being rotated in the y-axis, you can just draw them. You can reflect it in the y-axis and draw your solid. But that bit there that I'm drawing gets rotated about the y-axis. You're going to end up with a... Oh no, I've done it wrong. Sorry about that. Very bad. That's the sketch. Sorry, it's rotated about the y-axis between y is 1 and y is 4. I'm really sorry, guys. So it's like a trumpet, an open one, I think. Yeah, it's like an open trumpet. Bad drawing. All right, it's going to end up over here. It's like a trumpet. Sorry, guys. Very bad of me. Okay, it's like an open trumpet, so let's go. As long as you're following the formula, you're fine. Okay, so it's pi between the values of 4 and 1. X squared is y to the 4 dy, which is pi. Done with this one? All right. y5 on 5 and pi. Has anyone got the textbook open? Pick what you... I'll pick another one. I don't know. What's 4 to the 5 minus 1? What did we get? 1023 pi over 5. And then if you want, you can give some approximation. 19. Find the volume of the solid formed when that line is rotated about the x-axis. Main thing is that you write out the formula. And that's your main thing. If you do that, you really won't get into trouble. But if you don't do that, you will get in trouble. So, the formula is, volume is pi B on A. You know, it's rotation about the x-axis, so that's the dx one. And it's the y squared dx. So you're going to have to rearrange your equation and come up with y squared. Got it? You know what you're doing? Is everyone working on question 19? Rearrange your line. I want y squared. Have we got it? Try it on your own. Are you rearranging it, making y the subject, and then squaring it? And of course it's going to be like a perfect square. Don't just square. You need brackets and squaring it. So we've got 3y is 1 minus x. Y is, dividing by 3, a third minus x on 3. Now what did we do? You put brackets around it. You don't just go 1/9 minus x squared on 9. It's 1/3 minus x on 3 all squared. Which is, you can either choose to expand it if you want. I don't know. Should we expand it? It's just worse. If you expand it, you end up with 3 terms for substitution. I think it's best to keep it. Now, let's just see what we're rotating, by the way. I've expanded it when I first did it many years ago. I'm not going to expand it this time. All right? Isn't that just a straight line? Guys, look. Y equals 1/3 minus x on 3. It really is just a straight line with a gradient of what? Negative a third and a y-intercept of a third. So it looks something like this. That's what your line looks like. Yeah, I've got a negative gradient, and it passes through y as a third. That's the y-intercept. It's not to scale. The gradient's negative 1/3. That's a negative gradient. So, and you're rotating about the x-axis between the values of x is 0, whoa, and x is 8. So you're actually rotating this thing, and some of it's going to go down and some of it's going to go up. You're going to end up with a solid like this, but it doesn't matter. You don't have to find this point of intersection and do that solid bit different to this one. It'll all work. See, this top bit gets rotated around there, and this bottom bit gets rotated up there. It doesn't matter. It'll all take care of itself when you do the integration. So we've got that volume is the integral between which values? 8 and 0 of 1/3 minus x on 3. You know what? Let's just do something. Oh, no, we're not going to do anything. We're leaving it. All right, let's integrate. What do you get when you integrate that? Oh, this is a bit of a... Thank you. dx. Good. What do you get when you integrate? Girls, that is of the form ax plus b to the n. I will show you the other way that I did this. So don't you just write out the whole thing. Oh, this is a bit of a minus x on 3 to the 3 over 3 times the coefficient of the x, which is negative a third. Now that looks really good because 3 times negative a third is just negative 1. Between the values of 8 and 0, now I'm going to have to continue here. So it equals pi. Instead of putting over negative 1, why don't I just put a negative here? 1/3 minus x over 3 cubed between 8 and 0. Now I'm going to move down. Wait a sec. Tear this off. Move this here. Which is, see, because you get the negative, sorry, I'm covering half of it. Because you get the negative 1 down the bottom, so let's just put the negative out the front. You get pi. Actually, can we stick that negative out the very front too? Put negative pi, 1/3 minus x over 3 cubed between 8 and 0. I've thrown that negative pi out the front. So let's go. Negative pi times. What's 1 over 3 minus 8 over 3? What's that? Minus 7 over 3 cubed minus 1 over 3 minus 0 over 3 is just 1 over 3. 1 over 3 cubed. Isn't that just, what's the denominator going to be? 27. And you've got negative 7 cubed minus 1. Like you can do that all as one go on the calculator. 7 cubed, isn't that 243? Isn't it negative 244? What'd you get? Is that what you got? Is 7 cubed 240? Oh, I made a mistake. 344.
It's 343.
Yeah, and then minus 1 is minus 344. So it's negative pi times negative 344 is positive 344 pi over 27. 8, no, that's not divisible by 3. And that's it. Units cubed. I don't know what they've got in the back. Now, are we okay? Be very careful with this. You know, there's lots of places you can go wrong. I took that negative out. You don't want to be doing a negative substitution, take away a negative substitution. There's nothing worse. So I've pulled that negative out to the front to stop the idea of substituting negatives twice. Okay? Now, the other way of doing this, if anyone tried it, was to do this. Everyone got that? This is the other way of expanding that to 1/9 minus 2x on 9 plus x squared on 9. So, but the only thing is you end up with 3 terms. Actually, it's not too bad because you ended up with a 0 when you substituted the 0. You get the same thing. Either way would have worked, all right? Look, if you think you're going to make a mistake without expanding it, then go for this other way, all right? If your calculator savvy, if you don't mess up your calculations on your calculator, you could do this other way. All right? Next question is 21, exercise 3.9, the area bounded by those curves and the x-axis. So that's how you know what you're doing. So you've got y equals x squared like this. Y equals x minus 2 squared is like this at 2. Point of intersection, you can just do table of values. When x is 1, y is 1 for this y equals x squared curve. And when x is 1, y is 1, point of intersection is 1. Now, if I zoom in on that,
How is it rotating?
that volume is rotated about the x-axis. So you just draw the mirror image in the x. You'll end up with a solid like that. So, yes, you must break it up into 2 pieces. All right, because one of the areas is below one of the curves. I might just draw it large, a big drawing over here now. I don't know if it's any better. So over here, see, if this is 1, you have to do the first volume gets rotated here. That's your first volume. And anyone got a coloured, someone grab me my pencil case. Yep. So that one, you do from 1 to 0 of the first curve. See, this is the curve. The one that I've done in the blue is y equals x squared curve. The other curve is y equals, and I'll do black. Y, this is Najashri's fault. Y, it's because I've got, is, oh, purple. Yes, 2 volumes.
That doesn't work.
Y equals x plus 2 squared. No, x minus 2 squared. Now, that's this curve. And the volume, when that gets rotated, is there. So we've got, no. So therefore, we've got 2 integration volumes. We're rotating with respect to the x-axis. So write out the formula. Volume is pi b on a y squared dx. So we need y squared for each of those. The first one, if y is x squared, then y squared is y squared. It's x to the 4, isn't it? And the next one, y squared will be x minus 2 to the power of? To the power of what? 4. So we've got our purple volume and we've got our blue volume. And the original curve on this side is y is x squared, so y squared is x to the 4. This one is y is x minus 2 squared, so it's y squared is x minus 4 to the power of 4. So therefore the volume will be the combination of the blue, which is from 1 to 0 of what do I write? X4 dx plus pi from where to where? 2 to 1 of x minus 2 to the power of 4 dx. So you're doing two volumes side by side for question 21. And we get pi. All good? x5 on 5 between 1 and 0 plus pi. What do we do? This is of the form ax plus b to the n. That times 1 between 2 and 1. So substituting in 1, you get 1 over 5 minus 0 over 5, which is 1 over 5, plus pi. 2 minus 2, you're lucky, is 0, minus, be careful, minus, 1 minus 2 is negative 1 to the power of 5 is negative 1 on 5, which is pi on 5, isn't this plus? Plus pi on 5. So I've got 1 over 5 minus 0 over 5 plus pi, 0 over 0 to the power of 5. It doesn't matter if they're the power of 5. And you end up with 1/5 pi plus 1/5 pi, which is 2 pi on 5 units cubed. Okay, that's that. So for homework, can I just email you? You'll obviously be doing question 20 and any other harder ones that I didn't do. All right, next question. The next question is question 17. Here we go. Question 17. Find the volume of the solid formed when this curve is rotated about the y-axis from y equals 1 to y equals 2. Again, write the formula out, you don't have a problem. I think we're going to have to get and do some harder ones. So while you guys do these, I'm going to go and... So question 17, if you're not sure what it looks like, square both sides. Y squared is 4 minus x squared, so it is x squared plus y squared is 4, which is it comes from a circle, so it's a semicircle, the positive, because it's y equals, it's the top, it's above the x-axis. If it was x equals, it'd be sideways, all right, but y equals square root of 4 minus x squared is that. But it doesn't matter even what it looks like. We know that this is 2, and this is 0, and that's 2 and negative 2. But it's rotated about the y-axis. Didn't I do something like this before? It looks like, that's the cap. We've done the same question. It's very similar. And it gets rotated about the y-axis. So about there. Is it the same question? But where was it rotated? The other one was the y-axis. Same question? Oh, forget it. We're not doing that one. We've already done that. We've done that. Should I fix my video? Bad luck. They could suffer. Right.